thank you so much for being here. This is the AAL MICS, stands for AI Accelerator Lab, represents Major Innovative Constructive Showcase. And this is a recurring interactive showcase which spotlights breakthrough work from founders and innovators and researchers in AI and, of course, adjacent creative technology fields. Each session is designed to foster exposure, meaningful connections, and knowledge sharing, which drives both individual growth and collective advancements in the APAC innovation ecosystem. So I'm very, very overjoyed today to have our guest, Dr. Tanya Tsui. So Dr. Tanya Tsui is a researcher at the Institute of Environmental Sciences, Leiden University in Netherlands, working at the intersection of spatial data science, urban planning, and material transitions. With a background in urbanism and architecture, her work spans two complementary areas: understanding how cities can transition to a circular economy and developing geospatial tools to advance bio-based construction. So in her current research, Tanya leads spatial analysis work on the Rawproject, which investigates the environmental impact of digitally fabricated bio-based construction products. Her GIS work maps the availability of these bio-based materials across Europe to support more sustainable and locally grounded construction projects. So I can go on and on about Tanya, but I'm going to actually now kickstart and talk to Tanya herself. So thank you so much, Tanya, for being here. How are you doing today?
Good. Thank you for having me. I'm excited to chat with you.
Yeah, me too. Actually, Tanya, we've been friends for quite a while, actually more than half of our lives. So this is actually very meaningful for myself because I've always admired the way you work. In fact, I remember precisely you used to wake up at the wee hours of 5:30 to 6 a.m. just so that your mind could be super clear when you do your work in the studio. And if that's not dedication, I don't know what is. And fast forward, you've now done postdoc years in MIT Sensible City Lab, and then you've of course done your PhD before that. So you have advanced so much. It's so good to catch up on where you're at right now.
Oh, thank you. I wish I was this disciplined now. I have no idea how. Have you noticed? I don't know about you, but like for me, I noticed when I was way younger, I was way more disciplined. Now I have no discipline. I wake up at like 8 and then I'm like at the office at 9:30. No more discipline.
That's still very understandable. Currently, what is driving your curiosity at this very moment?
Oh, that's a good question. What is driving at this very moment? That's a good question. Well, okay, so like maybe we can already dive a little bit into my research. So I've
Sure.
always been really interested into spatial data science. So like basically the analysis of location and a lot of maps and how location affects different things.
Yeah.
And I'm also now working on looking at bio-based construction materials. And I think, there's going to be a large transition, at least in Europe or in the Netherlands, towards using more
Mm.
bio-based materials like timber or different bio-based fibers. And what I find really interesting about these materials is that they're really like location dependent because like you can like wood is grown in forests, like different biofibers, they're grown on fields. And so there's a lot of spatial data that's involved in bio-based construction. And I'm just really curious about how when we transition to more bio-based materials in the future, how that will affect the movement of materials, the logistics of it, where materials get produced, where they get stored, where they get used. That's like always the thing that makes me really curious. The whole idea of like logistics and spatial planning and using spatial data to make these spatial planning decisions. And now I'm specifically interested in bio-based materials. And the cool thing about bio-based materials is also that there is a lot of spatial data available. So we have spatial data on where forests are, where different crops are, where, different plants are. And so that's really exciting for me as someone who works a lot with spatial data.
Okay, got it. Can I ask, when you're dealing with data, what kind of form are they? What do they look like? What does data look like for you?
The data I mostly work with is spatial data. So they're basically maps, and they can come in two main forms. One is raster data, one is vector data. I think our audience will know vectors and rasters very well because they're architects. But in the, let's say, in the world of spatial data, vector data means data that's points and lines and things like that. So if you look at Google Maps, like there are lines representing buildings and roads, and there are points representing, where restaurants are and things like that. So that's vector data. And then raster data is what you would think it is. It's basically a map with pixels. So each pixel represents a value. So those are the main types of data. I work with both.
And Tanya, at the very beginning, when you were doing your bachelor's, you were studying Bachelor's of Architectural Studies. So that course actually would be guiding people to finish off and become an architect. So you've actually had a pivot. In fact, you've gone down the research route and you've done your PhD. What made that change? Was there like a moment you realized, okay, you actually want to go down this route to look into spatial data and bioconstruction? Was there like a point somewhere in those years when you realized that's actually what you want to do instead of being a design architect?
Yeah, for me it was so when I started my bachelor's in architecture, I was honestly not that into it. Like I just picked it because I didn't know what else to do. And so I was actually quite lost for a while during my bachelor's. And then after my bachelor's, I decided, you know what, like I don't know what I want to do, and I'm not sure if I like architecture, but since I don't know what else to do, I'll just like put all my effort into this thing. Might as well try my best. And then I had some like interesting years working as an architecture assistant and also doing my master's in architecture. But then I did my master's in TU Delft. And there, for your final project, you have to spend one semester doing research. So you had to write like almost like a research paper. You don't have to publish that paper, but you had to write a research paper. And I really enjoyed research, and I realized I liked research way more than design because now looking back, I realize it's because my personality is more suited for research because I think I am a above average curious person, but in terms of creativity, I'm like pretty average. I'm like average creativity, but really, really curious. So I think it's suitable for research. And so like when I was doing my master's thesis and realizing that I enjoyed research, I just kept telling everyone that I was interested in doing research and I wanted to transition to, out of architecture in some way. And then I got really lucky because one of my teachers had like some research funding and he was looking for a research assistant. Like my teacher was called David Peck, and then he gave me the opportunity to be a research assistant for 1 year. Quite liked that. And then he won more money for someone to do a PhD and he asked if I wanted to do it. And so I ended up doing a PhD. So it was all very like a haphazard and unplanned. And then when I was doing a PhD, that was during the COVID times, during the pandemic, and I just had nothing to do at home. So I learned how to code. And then I realized I loved coding. I was just like really addicted to it. And so then I sort of moved my PhD so that it would include some kind of coding. And also I realized I really liked spatial data science, so coding with maps and things like that. So that was how I started.
You're so modest. You make it sound like everything happened because it was quite haphazard, but I know you worked very hard. In fact, can you tell us what are the key elements that a good researcher should have? Like, what are the traits of a good researcher?
A really good question. I think it depends on what kind of researcher you want to be. I guess all I can say is like what I aspire to. I think there are different kinds of good researchers. But for me, a good researcher is someone who's like really curious and really open to different ideas. Is someone who's like is collaborative. I think in academia, it's really easy to become really competitive and really
Uh,
like very like tit for tat and kind of very like always like whatever you do, you're trying to get something out of it and you're trying to
right,
get an edge and you're trying to be better than everyone else. I think it's very tempting to do that. And that is kind of generally what academia is like, at least for
right.
some parts of academia. I think I aspire to be something different from that, which is I've seen other academics who are more collaborative and helpful and open and willing to share their knowledge and ideas. I think
Mhm.
that's, yeah, really important. Like, I think it also makes you, it does make you a good researcher, not only in terms of like being a good person, but also your research becomes better. I think I do believe that if you're
Mhm.
like generous with your ideas and your time
Mhm.
and things like that, you
Yeah.
can get a lot in return. I think
Mm.
my current boss is a bit like that, and I'm I guess really also quite inspired by her. So then I also aspire to be kind of an academic like that.
Wow, that's really nice. Because yeah, like you said, I don't think everyone is not gatekeeping, right? Because I think a lot of times people like to ask for credits and they like to compete. And I think it's really nice to be working in research in a non-political environment and also have a boss that supports you and be very generous with the ideas. My next question is actually about how does research turn into real world applications which can make an impact. But I will save that question until maybe after your screen sharing, because perhaps my question would be answered during your sharing. So whenever you're ready, please feel free to share your screen.
Okay, cool. Give me a sec. Let me share my screen. Okay, can you see?
Yeah, we're seeing the circular bio-based construction page.
Yeah, exactly. Okay, great.
Nice.
So, yeah, let me introduce the work that I do, which is looking at circular bio-based construction at the city or regional scale. So, the main problem statement of my research is that the construction industry has a large environmental impact in terms of its material use. And so, as a result, many countries and regions are pushing for a construction industry that's more, transitioning towards a circular economy and to use bio-based materials. What this means, maybe for those who might not know, like a circular economy is basically a paradigm that allows you to see waste as resources. So instead of taking materials out of the ground, using them, and then throwing them away, how can we use waste as a new resource using different, strategies like reuse or share or remanufacture or recycle? And in the context of a construction industry, this actually changes the way we move and store materials. So instead of taking materials from factories and from mines, we're going to take materials from demolition sites, store these materials, and then redistribute them. So it kind of changes the way, from the perspective of a like urban planner or an architect, you can see that it changes the way that cities plan their spaces. You would need space to fix products, you would need spaces to store things and move materials. So this is what the circular economy was about and also what my PhD was about. And then now I'm also interested in looking at using bio-based materials in buildings as well. And again, this changes the way we use space. So where materials are being grown, where they're being stored, where they're being manufactured, it changes all of that if we change the use of materials. And the interesting thing about circular bio-based materials is also that they're not as homogeneous as other types of materials. So for example, circular materials, so let's say if you take waste materials from demolition sites, there's more variation in terms of structural performance or dimensions than virgin materials. So if you're an architect and you want to build with, let's say, reclaimed timber, it's more challenging because as you can see, for example, on the screen, like this is pieces of reclaimed timber. They all are shaped a bit differently. They have different defects. They have different strength performances. And so you have to, when you make a design, you need to take that into account. And the same is can also be said about bio-based materials. They have more variation than abiotic materials like steel and concrete because they're natural materials. So each tree is grown differently. They have knots in different places, and that affects the structural performance. And there's a wider, for the same dimensions of a timber beam, there's a wider variation in terms of structural performance than, let's say, if you had same dimensions of a steel beam. And what's interesting for me is that this variation is also location driven because like in different locations, you have different types of bio-based materials growing because of the local climate. You have different types of trees, different types of bio-based fibers based on where your location is. So you can imagine that in the future, if we were to build cities out of bio-based materials, they might look really different based on the region. Like this region has these types of plants, that region has that type of plants, and it will have more variation in that way. And so now I'm working on a research project. It's a large research consortium. So it's not just me, it's like multiple universities. And the project is called the Raw project. And it looks at how digital fabrication can be a solution for this increased material variability. So trying to customize designs for that, for like the input materials that are varying all the time. So for example, on the screen, you see like they're designing like a structure that has three legs, but then the shape of the structure is allowed to change according to the input waste materials that are going into the structure. And yeah, we have three material tracks that we're looking at. We're looking at reclaimed timber, biopolymers, and bio-based fibers. And the case that I'm looking at right now is the case of 3D printed biopolymers. So these are basically plastics that are made from bio-based products, and they can take a wide variety of agricultural or industrial waste flows as an input, as the recipe. And our idea is that these products can have more environmental benefits like carbon sequestration and nitrogen fixation. And the vision we have, this is an AI generated image, but the vision we have is we think of this like adaptive factory where we have these smaller scaled decentralized factories that take local bio-based materials from like local factories or local farms that have waste flows. And then you can take these materials and then turn them into new products. And because it's like digitally fabricated, you can have things at a much smaller scale. And each factory might have different kind of recipe mixes for the biopolymer based on what materials are available. And so the question we have is like, how can these factories make decisions on where to locate themselves and which ingredients to choose in order to maximize the environmental benefits and also minimize environmental burdens? And so, yeah, I looked a bit into literature. Maybe I'll skip this a bit. We can get back to it if we want to talk about it more. But basically, in existing research, there's already all kinds of ways to use environmental impact assessment methods to help factories or designers make decisions. A lot of these methods boil down to something called LCA, so life cycle assessment. And so basically there's a lot of work on how to use LCA to make different decisions, like, what kind of design to make based on LCA, what kind of manufacturing methods to use, where to locate these facilities. What I want to do is to make a framework that allows a factory to make decisions both for location, so where to locate your factory, but also manufacturing-based decisions like what materials to use and what machinery to use and things like that. I'm going to skip this. Will I skip this? Yeah, I'm going to skip this for now. So to like make location-based decisions, you need to understand like what kind of materials are available locally. So I collected a lot of spatial data on material availability for all the possible ingredients of our biopolymer. So we have some partners who are chemists, and then they've developed like a biopolymer recipe. And these are all the materials that you could put into the biopolymer. And so basically I built a tool where you can pick any point in Europe, and then it will tell you how much of these materials are available. Oh, and now I can show you some fun stuff. So first is this recipe impact explorer. So you can see that for the bio-based biopolymer recipe, it comes in two parts. One is called the binder, and the other part is called the filler. The binder is basically the glue of the 3D print, and the filler is like the dust that you can put in that affects like the color and the structural performance and things like that. And so the thing is you can vary the proportions between the different ingredients and the types of ingredients you can put in. And then that affects the environmental impact of that recipe. So you can imagine if you change the recipe, it changes also, how it impacts the environment. And each of these bars is one kind of environmental impact. So there's like climate change, land use, eutrophication, and things like that. Yeah, so that was the first thing that we built. And then the second is something called the Factory Siting Explorer. So basically you can pick any location in Europe and then you can change the travel distance limit. So like what's the scale of your factory? How far are you willing to travel to get materials? And then within this travel distance limit, you can understand the material availability within that location. And then that changes the environmental impact of that location. So the idea is you can see with this tool, like how, yeah, the location that you picked affects the final environmental impact. And also the scale of the factory also does that. Yeah, I think that was it. Yeah. Shall I stop my screen share or shall we talk a little bit with the screen shared?
Yeah, if you don't mind, you can keep the screen on. Maybe you'd
Okay.
like to reference something. So, yeah, thanks so much, Tanya, for sharing this. I feel there's so much work in all the things that you've just shown. I actually have a lot of questions, so therefore, I feel very lucky I get to ask you questions for the next 15 minutes or so. And if the audience if you have any questions, feel free to also put in the chat. So, Tanya, I want to mention that a lot of your research is actually Europe focused. I kind of know why, but can you tell us why is it Europe focused? And I also wonder whether or not the same type of research could be applicable to other parts of the world. What do you think?
That's a really good question. Yeah, indeed, it's Europe focused because I'm just based in Europe and like my research is funded by usually European funding. So that's where I first start. But indeed, I would be really interested in expanding this research to the rest of the world. So a lot of the data that I use is globally available. I didn't create this data. I'm just like downloading it and
Mm,
synthesizing it. So for
yeah.
example, the material availabilities, a lot of these base maps are global. So I
Mm,
could have also have done like a map for the entire world, but it's just that, yeah, for me, it's just
mhm,
easier to do it for Europe. I guess also like applying it to the rest of the world might be a bit harder because, yeah, different
mhm,
climates have different vegetation and different tree types. And so it needs another kind of expertise as well. But actually,
mhm,
what your question also touches on, like a really important point, which is that a lot of sustainability research happens in Europe and in North
mm,
America, in countries that are
mm,
really relatively wealthy and developed. But actually, the biggest impact we can make on sustainability is the rest of the world, like the parts of the world that are still growing and developing, like Africa, like Asia, like South
mm,
America. And so I don't do this work, but I have a few colleagues who are really interested in these regions and how you can make
mhm,
a better impact there. It can be like looking for solutions, like specific solutions that fit in those contexts to like creating data even. Like there's just not
mm.
even good data in those regions for you to be able
Yeah.
to do accurate research.
Got it. And can I ask, how does the data visualization and the methodology and the output of the research, how can it be applied in real world situations? Or
You
who are
mean
the beneficiaries of this data?
Yeah, so I think so for example, what the stuff that I was showing, like for example,
Mm,
this kind of thing, I would imagine it would be for like a kind of factory that is making these 3D
mhm,
printed products. They can use
mhm,
this kind of information to
mhm,
improve their recipe and their manufacturing methods. I mean, that's kind
mhm.
of what we're trying to do now. I mean, like I'm
Right.
part of the environmental sciences group in Leiden, but
Yeah.
then we're working with these architects who are very
Mm,
specialized in 3D printing. We're also working with chemists. And so like the information that we give them, we can provide feedback for them so that they know, oh, we need to optimize this step of the 3D printing process because it's the most environmentally impactful.
yeah, of course. And do they give you feedback as well from what they do?
Yeah, I mean like so they have to tell me like what their current processes are
Work.
and then
Mm,
yeah, their workflow and then I need to based on that like do the assessment and then
mm,
it's supposed to be like a back and forth where yeah, we give each other feedback and I think
mm,
also down the line the thing is right now these products that I'm assessing, they're very early stage prototypes. So we also need
mm,
to start imagining like if this scales up, how would the environmental impact change? Because there's like, there's economies of scale.
yeah.
Also, like in the future, things will also be different. So, for example, energy systems will start
Hmm.
decarbonizing. And so, like, the use of energy will have less environmental impact than today. All of these things need to be taken into account. So, we also are going to start, so me and my project partners will start
Hmm.
talking about the future as well, like how they envision this future when this prototype turns into a fully scaled up product. What
Yeah.
will these factories look like? What will these systems and infrastructure look like? Yeah, so that would be
Hmm.
the next step of the research.
Very cool. I think the overarching intention here is to prompt the people who are working in the factories or people who are designing buildings, anyone who is involved in construction, to really think about where their materials are coming from. I would say from perhaps I'm quite ignorant. If I may, I think it can be boiled down to two parts. One is government policy that pushes people, they have no choice. They just have to follow mandates and they have to use certain amounts of, let's say, bio-based construction or certain certified materials. And I know that has always been the case. Like there had always been regional levels of mandates. And then the second one would be something that drives the economy. If it is going to be cost-wise beneficial, then it is a huge financial incentive for those stakeholders to make a move and to change their current processes to the better benefit of the society. So please tell me your thoughts. Like, are my thoughts on the right track? And if so, how can we help in both areas? Would this research become some kind of white paper for the government, or would this research also shows how by following these processes, there could be a benefit in their finances?
Yeah, I think the our research is mainly more leaning towards like the policy side and like
Mhm.
writing white papers and things like
Right.
that. So there's yeah, the two opportunities that we're looking at is Europe is starting a voluntary carbon credit market. So
Mhm.
kinds of products in the future could be sold, sort of the carbon credits can be sold on the market. So that can be a source of
Right.
income for whoever who's
Yeah.
making these products. But that
Mm.
really depends on like how that develops. Like right now it's just a voluntary market
That's
and yeah, the price of carbon is also varying across Europe. We're also working on baking these methods into structural standards. So one of the
mm,
big, how do you say, one of the big bottlenecks of using
mhm.
bio-based materials or circular materials is that they don't
Yeah.
fit the structural standards. And so it's
Right.
really
Right.
hard to test these materials. It's really hard to use these materials in a real building
Yeah.
because it's very hard to get past the building permit office because they're like, how do we know
Mhm.
this is safe? And then you have to
Sure.
do all kinds of tests to prove to them, like, I
Right.
swear it's safe, blah, blah.
Yeah.
And
Yeah.
so what needs to change with the building standards is also that it might have to be loosened, or you might have to give
Mm,
different standardized ways of testing reclaimed materials to basically
mm,
prove that okay, this material is safe enough to use in buildings. And this
mm.
has all kinds of consequences in insurance, in building
Yeah.
financing, and all of that. I'm not like a expert on that, but that's actually a huge
Mhm.
bottleneck. Yeah. And in terms of economy, I think mostly it's like, yeah, it's also right now, it's the thing is what we're developing now is very, very early stage stuff. So it's not something that's ready for
Yeah.
market, and it's not something that is gonna be like cheaper than like
Mhm.
what you have on the market right now, because
Sure.
these kinds of materials or these kinds of fabrication methods, they need a different, like a whole other
Yeah.
infrastructure that
Yeah.
goes beyond the factory, you know?
Yeah.
Yeah, yeah.
Right. Yeah, I like what you said. And I think you're right to say that to really scale up the bio-based construction, one needs a alternative infrastructure to the industrial revolution. And it just needs to be a parallel to that. And I think the industrial revolution brought together economies of scale, brought together modular designs. But I think after all these years, we also see the flip side of the efficiency, the flip side of the optimization, because now we're really seeing, well, we've got plenty of heat waves around Europe already this year. So I think that's all relevant.
Yeah, and indeed.
Yeah, please, please.
Yeah, I think it's like this goes into the field of transition, like transition theory.
Mm,
So there are people who, for example,
right.
if you look at China, they transitioned from diesel cars to electric cars over seemingly overnight, you know? But that like when you want like an entire region or an entire country to start driving a different kind of car, you need
Mm,
all of this infrastructure around this new product
yeah.
or
Yeah.
like solar panels and things like that. So these are yeah, transitions that can happen really rapidly, but it's not just having a new product, but also all of the infrastructure that
Mm,
surrounds it. So that's the same with
right.
bio-based construction. The construction industry needs to change in many different ways. The way we finance buildings needs to change, the
Yeah.
way you move
Exactly.
materials, the way we design, all of
Yeah.
that is transitioning as we speak.
Yeah, I think there's so many moving parts and there's so many pieces of the puzzle to move 1 degrees in this whole huge ecosystem. But that's what you're good at. You're very good at seeing all these moving pieces and then being very curious about each part of them. So this research, as it develops, what is your short-term vision for this research and what is your long-term vision for your research career?
Okay. Yeah, that's a good question. I think short term is to basically there's two big things that we want to produce in this research. The first is, well, it's basically what I'm showing here. So
Mhm.
refining this. So for example, this
Right.
is looking at the environmental impact of the different processes
Yeah.
of making these 3D printed biopolymers. And then we want to, like right now, the assessment is on what's happening in their lab in Copenhagen. So we're just
Mm,
taking those numbers and doing an environmental assessment of this
mhm,
sort of prototype making process. But then we need to imagine what it could look like in the future. So when this thing scales up, how will it scale up? And then how will it change the environmental impact of
mm,
this
mm,
product? So you have to think of two things. One is like how the processes itself they get more efficient. And then
mhm,
the other thing is the background. So like
mm.
the societal infrastructure, how that will change in the future as well. So that's a
Right.
method called prospective LCA. So thinking using
Okay.
LCA to think about the future. So that's the first thing we have to do. That's going to be fun because I'm going to imagine these futures together with the people who are making these products. And then the second big sort of product or result is looking at the spatial side of LCA.
Mhm,
So how location affects your environmental impact and using this as a case study. Right now, I'm only using location to determine the material availability, which affects the impact. But another thing we want to add is we want to assume that these factories have solar panels, and then the
mm,
location of the factory will affect the how much energy is generated from these panels, and that will also have an impact
mm,
on the final product. And I think that's pretty useful because a lot of factories need energy. Almost all factories need energy, and then almost all of them can use some kind of local energy generation. Yeah, so those are the two big things that I want to do. And then the long-term research vision, I'll be honest, I'm not super sure yet. I've always been interested in what you said in the
mhm,
introduction, like the connection between spatial planning, material transitions, and spatial data science. I mean, this is my dream. My dream is to run a small research group. Doesn't matter where. It can be in a
nice.
university, it can be in a company, it can be in a research, whatever. Just a small group of people doing research. And I want to and doing specifically research on the sustainability of cities and regions and from a
Mm,
materials perspective. So there's like sustainability research basically boils down to two main sides. One is looking at energy, how we use and generate energy, and the other side is materials, how we use materials. And so I want to look at the materials side of cities and regions. And then I want to co-chair this little research group with someone else who looks at the same topic, but from a social sciences perspective, from
mm,
a humanities perspective, someone
right,
who
right.
understands like social sciences, economics, philosophy,
Mm,
history, like this person.
anthropology. Mm,
Exactly. And then I will do the kind of more
mhm,
quantitative data science
right.
stuff. and we
Got it.
will lead a little. That's my dream.
I love it. You know, if I'm ever in the position to do so, I would love to fund your research group.
Excellent. Thank
It'd
you.
be one.
I accept the offer when you become a billionaire.
I know, one day, right? Okay, this is so cool. Yeah, I feel like a research group sounds really awesome. And I feel a lot of the work that you do, like the what you said about the overall picture, I think that reminds me of a domino effect. Like once you've sort what's happening in this lab in Copenhagen, how you can see them progress, and then that just becomes a template. And when others follow and everyone's doing kind of the new way, like transition, how does it look like all together in a city scale? So I think that is indeed very special. So yeah, as I've expected, this is pretty cool.
Thank you.
So I can see that we have a question, and for the audience who's here, please feel free to ask questions to Tanya. So thank you, Bosco, for this question. I really loved everything you presented today. I think there's definitely a much higher awareness in the industry of environmental impacts now, especially with the recent heat waves in Europe. Those threats have really been a wake-up call. Many have been already looking at alternative bio-based or recycled materials, etc., and trying to move past the traditional modernist view. However, I believe the biggest difficulty for the industry isn't a lack of innovation or research, but rather regulation. Right now, we have to prove these solutions work through smaller projects, often as a tough negotiation with local governments. In your view, when will we see a more extensive adoption of these solutions, and which parts of the world do you think will be the first to really move on this?
Okay, really, really good question. Yeah, I agree. I think in many, many research groups and meetings, we do see that there's like these kinds of solutions are not really rocket science. They're all technically feasible. And indeed, it's a issue of regulation and motivation from the industry. Like the construction industry is notoriously slow and traditional. I think that's the case for every country, at least in Europe and also in Hong Kong. That is the case. I don't know the rest of the world. So it's, yeah, indeed, there's a lot of sort of people, policy, regulation related barriers. When will we see a more extensive adoption of these solutions? I'll be honest with you, my view is very Eurocentric because I've been in Europe for so long, but I do think there's a lot of research and regulation that is starting in Europe. So for example, I think there are countries in Europe that have started, for example, carbon tax, so putting a price on carbon emissions. And so for example, I think Norway, I might be wrong, but I think Norway has, for example, the highest price on carbon in the world. But these policies can also have a really weird knock-on effects. So yeah, so for example, I know in Norway, they have a high carbon price, but as a result, because of this high carbon price, a lot of timber is being used to be burnt for energy instead of being used for buildings. So it's really dumb because like wood sequesters carbon, so it stores carbon in the material, and then when the wood gets burnt, the carbon gets re-released into the atmosphere. So the whole point of using wood is so that you should be using wood in products that last for a really long time, like buildings. Right? So then you get to store that carbon for 100 years, for 200 years, right? So the dumbest way to do with the carbon is to burn it. But because of like the high price of carbon, it makes a lot of financial sense for energy providers to burn timber instead of to burn fossil fuels. And so there's a huge financial incentive to buy up all of the timber to burn it because that makes most financial sense. So like I think there's also like the solutions are also not simple at all. Like you think, oh, like just make a policy and like increase the price of carbon, but then you have all these weird knock-on effects, which is why I want my dream research group to have this other amazing person who like understands this stuff. I don't, but they would. And I think who will be the first to move on this? I mean, the biggest players in sustainability research are, at least in my world, Europe and China. So I think they might be the first to move on this. In terms of bio-based construction, probably North America as well. So North America, Europe, China, I haven't heard that much about bio-based construction, but I don't know yet. Yeah. I hope that was an okay answer.
Of course, that's a great answer. And I have a follow-up. Even though you haven't seen China doing lots and lots of bio-based construction research, why do you think they are one of the big players next to Europe on this?
I think in terms of sustainability, China is really fast. One thing, yeah, they're just really fast. The energy transition is crazy. They're dominating the like solar panel industry. As I understand, I'm not an expert, but like that's my impression on it. And there's a lot of really good sustainability research coming out of China as well. I don't know. China also has like most of the rare earth metals in the world, and all those metals are used in renewable energy technologies like solar
Mhm.
panels and wind turbines and things like that. So they're like a huge, huge, huge player. But yeah, indeed, I haven't seen much on like bio-based materials, but they've done a lot of work on circular economy. So yeah, there's
Right.
just research coming out.
I'll send you articles if I come across any in my Chinese network, if there's someone that's really moving forwards with the bio-based construction.
Cool. Thanks.
So I have a quick question, Tanya. You mentioned that you self-learned coding during COVID when you were bored, and you are also very savvy with data visualization. I have a lot of people, actually a lot of previous audience members who've asked how can they pick up these skill sets, coding or analytics, data science. What would your advice?
I really, really loved this book called Automate the Boring Stuff. I'll write it in the chat. Automate the Boring Stuff.
So that's
It's
literally the
Yeah, that's
name.
the title of the book. And you can buy the book if you want, but the author of the book also made it free to download as a PDF. That was where I
Wow.
looked. And it was recommended to me by multiple people who were in software engineering. I guess the world is so different now, right? With AI, like I
Mhm.
barely code. I just ask
Yeah,
Claude code. But I think also it's really helpful to at least get the basics of it so you
the
understand,
principles.
yeah, the principles. And for anyone who's interested as well, there's like basically in the world of coding, there's two big worlds. One is data science and one is software engineering. So you can also ask yourself, like, am I interested in doing kind of statistics and research and stuff like stuff I'm doing? Or are you more interested in building tools that people can use? That would be software engineering. So you can also, yeah, think in there. Oh, and there's also a website called Kaggle.com. And that is for data science people. So I think it's a website that's started by Google, and it's a place where you can learn data science, you can get like free data sources, you can download data for free. There's like competitions on data science. That was also like, so I started with automate the boring stuff, and then I realized I like data science, then I moved to Kaggle, and then I just did my
Hmm.
own projects. I think also for me, the best way to learn is to just do something, like find something that you're interested in and excited about, and then just learn the skills that are needed for that thing. And that's for me the most fun way to learn.
Great. I love how practical those two suggestions are. So, Tanya, do you think there's something important about today's topic, about circular economy, about sustainability in construction, about bio-based materials? That is a very important topic, but we haven't spoken about it yet, or maybe people don't often talk about, and that you'd like to talk about now.
Let me think. I would say, like, we talked a lot about like environmental assessment and spatial data science, which is stuff I'm interested in. But I can imagine for architects, you might be asking, what's my role in this? How can I make a contribution? Even though I'm not a
Mhm.
researcher, I think architects are actually the main drivers of this, right? You're the ones who are talking to the contractor and the client and maybe the local municipality or whatever. And I think, yeah, I think architects have a huge role to play, and knowing how to design with these different materials is super important. And I do see that like me and you, we were out of architecture school for many years. But I do see some architecture schools teaching their students also differently. So instead of making a design and then figuring out how to materialize it, with different products and things like that. Designing the other way, so looking at what resources you already have and then designing with those resources. I thought that was it's a completely different way of seeing design. And yeah, I'm looking forward to how architects will design in the future.
That's great. I do think everyone should have a role in that direction. So I'm glad you brought it up. So Tanya, what does success mean to you? Would you be able to describe it in one word?
I think it's like for me, it's like I had two words in my head. I don't know which one's better, but one was fulfillment and one was wholeness. Yeah, I think maybe wholeness. Like, yeah, I think that's for me what success is. Like, I'm not someone who's really like, who wants to be very good at one thing and then being like the best in the world at this one thing. That's just not really my personality. I think I'm kind of interested in having like a whole life, like
Mhm.
all the aspects of my life at 80% rather than like one thing is 150% and everything else is
Mhm.
zero. It's like I don't think I would enjoy that very much. Yeah. And I
Right.
also see that actually in my work. Like I mean, my dream also, like, I hope that like the way I treat my colleagues is also like I don't just see us as people who have to produce research and like be the best in the field, but I also just want us to get along and see each other as human beings and have a good time together. Yeah, I think that to me is success, to not pursue like, like sort of material success and no matter what cost and forgetting everything else. I'd rather be like mildly successful and then like very happy in other parts of my life as well.
That's beautiful. Thank you so much. And thank you so much for your time. This is one of my favorite episodes, obviously, because you're here. And I really enjoyed it personally. So thank you so much. And thank you to the live audience who stayed till the end. And this will be on YouTube. And thank you again. I'm just very happy to have you today.
Oh, thank you for having me. I had a good time.
Thank you. And that's it for today. Bye bye.
Bye.